Hey guys, we are in the Geology for Competitive Examination lecture series and this will be lecture number 2. And today we'll try to cover the topic the hot springs, geysers and fumaroles. And for this topic I refer the books The Geomorphology by Savinder Singh and Dental Geology by V. Radhakrishnan. Welcome to my channel Success Guru and myself Panchanadam and let's get into the heading. Actually, what is a geyser? The area of a recent igneous activity, rocks in buried lava flow and old magmatic chambers can remain hot for hundreds of thousands of years. Groundwater migrated through this geothermal area, becomes heated, and this hot water may be discharged to the surface as thermal or hot springs and geysers. So this is what it is actually. And the term geyser is a special type of hot spring which sprays hot water and vapor from time to time. The word geyser has been derived from the Icelandic word Gesir, which means gusher or spouter. This word was used to indicate the sprouting of water of hot spring of Iceland known as Great Geyser or Gesir. So this right hand side you can see this is the geyser in the Iceland from which the term has been arrived. The difference between a hot spring and a geyser lies in fact that there is a continuous sprouting of hot water in the hot spring, whereas there is an intermittent gap in the emission of hot water and stream in geysers. That is the difference between the hot spring and the geyser. So let us see how it is formed. Okay, the condition necessary for the development of geysers are there must be a body of hot rock relatively close to the surface. The system of irregular fractures must extend downward from the surface, and there must be relatively large and constant supply of groundwater. So these are some of the minimum requirements for the formation of geyser. So groundwater is moving here, and here is the geothermal gradient which gives the heat for it, and there are fractures which connecting the surface to the underground. So and there is a supply of groundwater. So if these three minimum requirements are fulfilled, then the geyser will work. So let us see how it works. The hot water collected in the caverns and fractures, okay, the stream bubbles rises, they grow in size and number and extend to clog the restricted path of the geyser tube. So when there is a stream rise, it will try to clog the path, right? As the pressure builds up, the boiling point is raised up in that increases the pressure. So when there is a clogging, what happens? The pressure will try to rise, and as the pressure rises, the boiling point will also rise. The expanding stream forces the certain amount of water lying above upward, and the water is just discharged the surface. So when there is a pressure up, is pushing, right, so the water that is in this route that will be pushed out, and this reduces the pressure reduction lowers the boiling point. So when there is a release of pressure, the pressure will be dropped, right, and where there is a drop in pressure, that will also impact on the boiling point, that also will be reduced, and the water from the side chamber and the pore space begins to flash into stream. So when there is a sudden drop in the pressure, there will be a sudden drop in the boiling point, and all of a sudden what happens, the water will be converted into stream, right, and that is all called as a flash into stream. And this steam forces the water in the geyser system to erupt. So this is how the eruption takes place, and the openings are emptied and eruption ceased. So how much there will be conversion of stream, right, so that will be moving out, and what happens, the chambers will be emptied, and when the chambers is emptied, what happens, the eruption will be finished, that is ceased, right, and they are filled again. So once again when there is a free space in the chamber, what happens, the water will be recharged, and that will be fulfilling the chambers, and once again the process takes place. So this is how the geyser is working, right. So this is the process of formation for geyser. So let us see its types. The geysers are classified into two main types, that is the pool type of geyser and nozzle type of geyser. So you can see in the left hand side, is the pool type of geyser, whereas in the right hand side you can see there is a nozzle type of geyser. When a geyser spouts water through an opening and relatively large pool, it is called as pool type of geyser. Such a geyser spout large volume of water and vapor through a long geyser tube, and no deposits are possible around the geyser. Okay, so this is how the geyser is formed. The pool, it has a larger opening, so there will be no much deposits around it. Whereas in terms of nozzle type of geysers, the water spout of water and vapor through a very small and concentric vent that emits material, or that is the emitted material or deposited around the geyser and veins, and thus geyser cones are formed. So when the opening is small, what happened, the material that comes along with the geyser will be deposited around it, and that is why the nozzle is formed. So the nozzles material that is around the geyser is formed from the geyser itself. And I just want to introduce you one more term, that is the fumaroles. That is the fumaroles are the vents through which there is a emission of gas and water vapor. So here in the fumaroles you will be seeing only water vapor as well as gases, and there is no any what you call the water is not will not be coming out, right? So that it's such a kind of emission of gases only is called as a fumaroles. And the image you can see, this is a movie clip from Ice Age, Dawn of Melting, I think, right, in 2006. You can see there are so many number of fumaroles that appears in this region. So let us see what is a fumarole. A fumarole means a vent through which there is a emission of gas and water vapor. So you can see in this vent there will be emission of gas and water vapor, and there will be no any liquid form of water, and it appears from a distance place that there is emission of enormous volume of smoke from a particular center, and this smoke or gas emitted vent are called as fumaroles. So from which vent the emission of gases takes place is called as a fumarole. It is believed that the gases and vapors are generated due to a cooling and contraction of magma after the termination of a eruption of a volcano. So this happens near or around a volcanic region, and these gases and water vapors appears at the earth's surface through a narrow and constrict pipe. It may be pointed out that fumaroles are the last sign of activeness of volcano. So when there is a presence of fumarole, which indicates there is the volcano is in active stage. Okay. Numerous fumaroles are found in the group near Katmai volcano of Alaska. So the image you can see, this is that image in USA from Alaska. And here fumaroles are found in groups in extensive valley zone, which is called as a valley of 10,000 smokers, which means there are almost 10,000 fumaroles are present in this region with a diameter of around 3 meters. And here fumaroles are found along a linear fracture. So you can see the fumaroles line in a same line. Okay, and in other places you can expect fumaroles around in a circular pattern, that is around a volcanic crater. Okay, so these are some of the introduction about the fumaroles, and let us see the temperature. The temperature of a water vapor emitted from the fumarole is around 645 degrees Celsius. It may be mentioned that the vapor constitutes 98.4 to 98.99% of the total gas emitted from the fumarole. So in fumarole, you can expect the water vapor to be in terms of 98.4 to 98.9 percentage. And other gases includes carbon dioxide, hydrochloric acid, hydrogen sulfide, nitrogen, some oxygen and ammonia are present along with it. And some minerals are also emitted with the gas and vapor from the fumarole. So sometimes there will be emission of minerals also. Okay. Sulfur is the most important mineral, and fumarole dominated by sulfur is called as sulfatera or sulfur fumarole. Okay, so this is how it is termed as classification in fumarole according to its composition of emission. Okay. Okay, let us see why it is important to study a geyser or fumarole or even a hot spring. Okay, so the study of hot spring, geyser, and fumarole help us to understand the geothermal gradient in that region. Not only that, it can be utilized to understand the activity of the magmatic chamber. In fact, fumaroles are directly linked with the volcanic activity, and emission of gases and vapor begins after the emission of volcanic material is terminated in the active volcano. So when there is a in the eruption in volcanic region is terminated, then that will be continued in terms of fumaroles around it. Okay, so this is what they want to explain. And geothermal futures have great benefits. Some of its benefits are geothermal process create heat and electricity that provides power and hot water to the cities in Iceland, New Zealand, Italy, Northern California. So these are some of the uses, that is the importance of study of hot spring, geyser, and fumaroles. And with this, I am completing this video. As I mentioned, I completed the video within 10 minutes. And I grouped my videos according to the category that you can check in my playlist. You can connect with us by mail, Facebook, and Instagram, and these are the links. You can support us by like, share, and subscribe. Thanks for watching. Have a great day.